So today we are going to do tutorial sheet 6. And we are starting with the first exercise. So, if boys and girls are born equally likely, what is the probability that in a family with 3 children, exactly one is a boy? In a family of 3 children, exactly one is a boy. Okay, so what is the probability that if a child is born, it's a boy? Probability that it's a boy. What is the probability that if a child is born, it's a boy? Yes, it's 1/2. Yeah, it's half. Then what is the probability that the child is a girl? Then of course, it has to be 1/2 as well, yeah? Okay, now, what is our scenario? We have that in a family with 3 children, there are exactly 1 boy, and then it follows there have to be 2 girls. Okay, so what is the probability that this is the case? So, how can it happen? We can have that first a boy is born and 2 girls is born. Okay? Then, what is another way of this to happen? Then, first a girl is born, then a boy and a girl. And then, that a girl is born, another girl, and then a boy. So there are these 3 possibilities. Okay, let's see the first. What is the probability of this scenario? That is, what is the probability that the boy is born? We've seen that it's a half, so it's 1/2 times, what is the probability that next is a girl? It's again 1/2, so 1/2. Then again, the next one is a girl, is 1/2 again. So the probability...
3.
Sorry?
Not 1/3, Professor?
No, because the probability of that a boy is born is a half, and the probability that a girl is born is a half as well. That is, for each, the probability is half, half, half. Okay? And this is, first is a boy, and the second is a girl, and the third is a girl. Means we need to multiply. So it is half times half times half. That is 1/8. 1/8 is the possibility or probability, the probability of this scenario. Then here we have the same, because the probabilities are the same of a girl being born is half, then a boy is a half, and the girl is a half. So again, we have the same calculation. So this is 1/8 again. And the same is here, because half times half times half. So the probability of this scenario is 1/8 again. That is, we need to add them. So we need to add the probability of each scenarios, and then we get 3/8. 3/8. Right? Any questions to this?
Professor, if there are 2 children in a family and one has to be a boy, then the probability will be 1/2 as well, right?
Yeah, so if there is if you say that we know there are 2 children, and one is a boy, one is a girl, right?
Yes.
This there can be in 2 ways. The first one is a boy and second the girl, or the first one is a girl and the second is a boy. 2 ways. So what is the probability of this? 1/2 times 1/2, which is 1/4. For this is the same. So it's again 1/4. So it's 1/4 plus 1/4. So it's 2/4, which is a half.
Okay, Professor. Thank you.
Sure. Okay, next one is exercise 3.
What about question number 2?
How likely is it that the word manager will show if the letters A, E, G, R, M, N are shuffled randomly?
So we won't solve question number 2.
So we have letters. Okay, if we shuffle these letters randomly, what is the probability that the word manager shows up? That is, what we need is to calculate the total number of cases and the favorable cases. What is the total number of cases? That is, if we shuffle these letters, in how many ways can they appear? Putting it differently, how many permutations are there of these letters? How many permutations are there? How many ways can we put them into order?
7 factorial.
7 factorial, yes, the total number of cases is 7 factorial. 7 factorial, okay, because there are 7 letters. 7 factorial is the total number of possibilities. Then, how many ways can the word manager happen? That is, we have the word manager. In how many ways can we permute these letters in order to get the same word? In how many ways can I reorder the letters in order to get the same word?
There are 2 A's, so definitely 2 ways.
Yes, exactly. We cannot change the place of any other letters because G has to be here and there is no more G, E has to be here and so on. So it's only the 2 A's which can be swapped. Okay, that is, there are 2 arrangements.
Yes.
So 2 over 7 factorial. So it's 2 over 5040, which is 1 over 200.
Professor,
Yes?
we won't solve question number 2.
Question 2, I will cover tomorrow. Tomorrow tutorial from 10 o'clock.
Okay.
Then, are you okay with this? Any questions to this?
Can you please repeat the last section, 2 by 7 factorial?
You mean the 2?
Yeah.
So we have the word manager. Okay. In how many ways can we rearrange these letters to get the same word manager?
Mhm.
Can we move the R, for example? Can we move it somewhere? We
No.
cannot, because
No.
then the word manager won't show. It will be something different.
Exactly.
Can we move the E? We cannot.
No.
It has to be here. So what is the only thing we can move? Only the 2 A's we can swap, because then we get the same word. So there are 2 ways. Either this A is here and the black is here, or the other way around. So there are 2 ways we can put these letters into order to get the word manager. So that's how the 2 comes from.
Okay. Thanks.
Sure. Okay, exercise 5. Exercise 5. The company John Lewis and Partners knows from past experience that the number of TVs sold at a particular store each day has a Poisson distribution with lambda equals a half. what is a good approximation for the probability that this store sells no more than 3 TVs today? So we have that a store sells televisions. Okay. They tell us that it follows the Poisson distribution. What is the Poisson distribution? Poisson distribution means that the probability for a random variable to take a particular number is lambda to the power of k over k factorial times e to the minus lambda.
Professor, can you please use black marker instead of red one? I cannot see the board clearly.
Let's see if I... So lambda to the power of k over k factorial times e to the minus lambda.
Still not visible, Professor.
Can you see now?
No.
Oh, can't.
Professor, do you have black marker?
But they are running out.
Yeah, this one is yeah better.
Let's see. Let's see. Can you see this?
Yeah, better.
Yes, Professor.
Okay. So the probability that random variable takes some value xk is found with lambda to the power of k over k factorial times e to the power of minus lambda. Okay, what is the k? What does k stand for? What does k mean? K means the number of events happen in the time interval. The number of events which happen in the given time interval. In this case, what is the event? In our case, in this exercise, the events are the
TV
selling televisions. Okay, selling televisions. That is, K means the number of televisions being sold today. K means the number of televisions being sold in this exercise. Lambda, what is lambda in general? What is lambda in general? Lambda means the expected value, that is the mean. The mean. Lambda means the mean. Mean or expected average expected value. Okay, in our case, they tell us that the average selling is a half. So in average, half of a television is sold a day. Of course, it's not possible to sell half a television. It's an average, right? So one day 0 is sold, another day 1 is sold, and the average is a half. So lambda is the average or mean. Okay. Now, what is the question? Let's see the question. They ask, what is the probability that no more than 3 televisions are sold? No more than 3. So if it's no more than 3, what can it be?
2.
Yeah, it can be 2, yeah.
1.
1.
0. 0.
0.
0, 1, 2, and 3.
And 3, yes, because 3 is not more than 3, right? So if it's not more than 3, then it can be 3, 2, 1, or 0. Yes. Which means that we need to calculate the probability of each case. So we need to calculate the probability that 0 television are sold. Then we have to calculate the probability that 1 television is sold, the probability that 2 televisions are sold, and the probability that 3 televisions are sold, and we have to add these probabilities. We have to add these probabilities. So how do we calculate this? We plug 0, 1, 2, and 3 into the formula in the place of k. In the place of k. Okay, so the k means 0, 1, 2, and 3. How many televisions are sold? The lambda is given because the lambda is a half, is given in the exercise. Okay, it will be given for you. So let's do that. 0 television is sold, that means lambda is a half, raised to the power of 0 over 0 factorial times e to the minus half plus, now k is 1, so half raised to the power of 1 over 1 factorial times e to the minus a half. Then half raised to the power of 2 over 2 factorial times e to the power of minus a half, and the last one, half raised to the power of 3 over 3 factorial e to the power of minus half. Okay, so we just put 0, 1, 2, 3 in place of k into this formula, because the k means the number of events happen in the time interval, in the given time interval. And we can see that e to the power of minus half is a common factor, so we could have written it as e to the minus half and then factorizing. Okay, but anyway, the result is 0.998, which means it's very likely that no more than 3 televisions will be sold. Any questions to this? So again, this is called a Poisson contribution. The distribution, of course, distribution. I don't know why I say contribution. Poisson distribution. Okay, next one is exercise 8. Exercise 8. In a company having 80 employees, 60 earn 10 per hour and 20 earn $13 per hour. Determine the mean earnings per hour. Okay, mean earnings. So how do we calculate the mean, or in other words, expected value? Expected value. Mean or expected value is calculated, then we need to add up sum each value multiplied by its probability. Each value multiplied by its probability, and we add them up. What values do we have now? We have that some people earn $10 an hour and some people earn 13. So these are the values, the x values. Now, what is the probability of earning? So let me write it here instead. X1 equals 10, X2 equals 13. What is the probability that someone earns 10 an hour? How can we calculate that? We know that how many people earn $10 according to exercise? It's 60 over out of how many? What is the total number? Total number is 80. So the probability that someone earns $10 is 60 divided by 80, because 80 is the total number of employees. That is, it's 3/4. Then what is the probability that someone earns 13? That the number of people earning 13, which is 20, over the total number of employees, That means it's 1/4. The two has to add up to what? The two probabilities have to add up to what?
To get the mean value.
So even without calculating this, from this that the probability of x1 is 3/4, how could we have thought that the probability of the second is 1/4? Because the probabilities add up to 1, right? The sum of the probabilities have to be 1. And if this is 3/4, then the other one has to be 1/4, so that the sum is 1. Right?
Yes.
So now we substitute it in the formula. We take 10 multiplied by its probability, which is 3/4, plus we take 13, the other value, multiplied it by its probability, 1/4, and it gives us 10.75. $10.75 is the average earning. Any questions to this? Someone should mute their microphone. Guys, will you please mute your microphone? Someone's microphone is on. All right. Next one is exercise 9. Next one is exercise 9. It is a very important exercise. Not difficult at all, but it's important. So please know how to solve this, okay? We have x values 8, 12, 16, 20, 24. And their probabilities 1/8, 1/6, 3/8, 1/4, and 1/12. So similarly, and as in the former exercise, we have x values and we have their probabilities. Just now we have more than 2 x values and of course with their probabilities. What we need to calculate is the expected value, E of x, expected value or mean, which is calculated in the same way as we did in the former exercise. So we need to add up all the axes multiplied by their probabilities. So we need to multiply each x value, each outcome with their probability, and then add them up. So we have 8 times 1/8 plus 12 times 1/6 plus 16 times 3/8 plus 20 times 1/4 plus 24 times 1/12. Okay, so each x is multiplied by its probability, so these pairs, and then add them up. And in this way we get 16. 16. Then we need E of x squared. E of x squared. E of x squared means we have the same formula, but now instead of x, we need to write x squared. So it equals the sum of xi squared p xi. That is, we need to square each x values and then multiply by the probability. So we have 8 squared.
Don't we take square for probability as well? In the
Sorry,
formula. Don't we take square of probability as well? P into x of I whole square.
I don't. Can you say it louder, please? I can't hear.
Ma'am, she's
Yeah.
saying that can we have a, do we have to take the square of the probability?
No, no, only the x values, x squared. The probabilities remain the same as they were. So the probabilities remain 1/8, 1/6, 3/8, 1/4, 1/12. Here we only square the x's. So these are the x's. We square the x's only. So we have 8 squared times its probability, which is 1/8, plus 12, or I can see it here as well, 12 squared times 1/6, plus 16 squared times 3/8, plus 20 squared times 1/4, plus 24 squared times 1/12. Okay, so we only square the x's and multiply it by their original probabilities. This gives us 276. Then we need to find the variance of x, which is we take e of x squared, what we have just calculated, and subtract e of x in the first row squared. That is, e of x squared is 276, okay, because we have just calculated it there. E of x is 16, so minus 16 squared. So here we have e of x squared. So first we squared the x's and then add them up. And then in here we have e of x. And when we have the final result, we then square it. So this equals 276 minus 256, that is 20. This is the variance. Any questions to this? So again, important exercise, please know how to do it for the exam. Right. Okay, next one, exercise 10. Exercise 10. On a final examination in mathematics, the mean was 72 and the standard deviation was 15. Determine the standard scores of students receiving the grade 60 and 93. So we have that. We have two data points, 60 and x2 is 93. These are the two data points. What we know that the mean is 72 and the standard deviation is 15. So these are given. We need to find the standard scores. Standard scores. How are standard scores calculated? Standard scores are denoted by Z, and they are calculated as taking the data point, subtract the mean, and divide by the standard deviation. Take the data point, subtract the mean, and divide by the standard deviation. So we get Z1 as 60, first data point, minus 72 over 15, which is minus 0.8. Similarly, for Z2, we have 93 minus 72 over 15, which is 1.4. Okay, so these are the standard scores. So again, what we did, we took the data points, subtract the mean, divide by the standard deviation, and that is it. All right, then yes, next one is also what is this number? It's everything is the last exercise is number 11, I think. Number 11.
Yes, ma'am.
All right. The mean weight of 5 male students at a certain college is 151 pounds, and the standard deviation is 15 pounds. Assuming that the weights are normally distributed, find how many students weigh between 120 pounds and 155 pounds. Okay. So what we have is we have 500 students whose mean of weight is 151 pounds, and the standard deviation is 15. Is 15. Okay. Now we need to find how many students weigh between 120 and 155. Assuming that the weights are normally distributed. Assuming that the weights are normally distributed. Okay, what do we do with this information? First of all, so we need to find the students in the range of this interval. Weight interval. So, if we assume that the weight are rounded to pounds, I mean to whole numbers, then but students can have decimal pounds. So for example, someone can weigh 130.6, right? Or someone 140.5 or anything. That is, what is the lowest, what is the highest number which is rounded to 120. So what can a student weigh, which is rounded to 120?
199.5 to 120.
Very good, exactly. So 119.5 and above is rounded to 120. And then what is the highest number?
55.4.
Yeah, but let's take it to 155.5, let's say. But anyway, 4 is better, but that's okay. So we are looking for the number of students which falls into this range, to this range. What do? We calculate the standard score as we have done in the former exercise, which means data point take away the mean over the standard deviation. So Z1 is 119.5 take away the mean divided by standard deviation. This equals minus 2.10. And for Z2, we have 155.5 minus the mean over 15. This is 0.3. Nice. We have the standard scores. Up to here, it's easy calculation, right? Up to here, it's not difficult. So, what do we do with these values? What do we do? What shall we do with this information? What shall we do next? So, we have calculated the standard scores, and we know that this weight follows the normal or Gaussian distribution. Okay, and since they are standardized, this is the standard normal distribution. That means that if we draw the curve, it is symmetrical on the y-axis. What is this curve? This is f of x, that is the density or distribution function. And in this axis, we find the z values. So we have, let's say, minus 2.10 here, and then we have 0.3 here, let's say. It's not very proportionate, but it's okay. So we want to find, how do we find the number of students falling into this range? What do we need to do? We need to find the area under the curve between these two limits. The area under the curve between these two limits. How do we do that? How do we find the area under the curve? How do we find
Integration?
Integration, very good, exactly, very good. Integration, that is, we need to integrate f of x between these two limits. And then, what is the result? When we integrate it, we get the capital F function. We need to substitute the upper limit, take away the lower limit, right? This is how we did the definite integral. Okay, but now how can we find that? How shall we know? How do we know what are these values are? What we need to do is to go online and find the Z table, and check these two numbers. The Z table gives us, if you type this number, 0.3, it gives you the area of this curve from the beginning up to 0.3. That is this area. Okay, but we only need this area, so we don't need this. What shall we do? We write the Z value minus 2.1 into the Z table, which gives us the area of this small piece, and then we subtract this from the former one. That is FB minus FA, or F of 0.3 minus f of minus 2.1. So you find the Z table online. You type this data, this point, 0.3. You get a number. Then you type this number, you get another number, and you subtract it. And if you do so, we get 0.6. Which means how many students we fall into this range? 0.6 is probability, that is 60%, right? 60% of what? The total. Someone should do the microphone. So 500 is the total number of students, and 60% falls into this range, which is how many? 500 times 0.6, which is 300. Any questions to this? Any questions to this?
We'll find the Z value of these two, 0.3 and minus 1.2, and then
Yes.
we'll subtract them.
Yes.
And the value we'll get will be 0.6. And we'll multiply 0.6 with 500 to get the 300. Is that right?
0.6 is the area under the curve, which gives you the probability.
Okay,
So the
perfect.
probability is 0.6 or 60%.
Perfect. Got it. Thank
Right? And then you take the 60% of the entire number. I mean the total number of students. Any questions?
We take 19.5 because we were including 120 and 155, right?
Yeah, because basically the ones which are counted, the students which are counted to the 120 also involve those weighing between 119.5 and 120. So to count them as well. But anyway, this more difference, if you just take this, I don't think it will make a big difference. But he wanted us to be precise and consider the two limits. In which two limits? Right? In case that in our data we have only whole numbers, so the one who made the measurement rounded the ways up to a whole number. So in this case, we count those students in between 919.5 and 120, and 155 and 105.5. Okay, because some students might fall into this range and this range.
Yes.
Okay, any other questions for this? Okay, then we will solve the rest of the exercises tomorrow from 10 o'clock. Tomorrow from 10 o'clock online again. And I will cover the exercises for which we didn't have time today. So the rest of the paper.
Yes, Professor.
Okay, Professor.
And next week, Wednesday, I will have a drop-in session as well.
Yes, right.
Ma'am, when on next week we are going to start the tutorial 7, right?
Yes.
We are still